Voyager 1 was never expected to become humanity's longest-running explorer. Launched in 1977, its original mission was to study Jupiter and Saturn before quietly fading into the darkness beyond our solar system. Decades later, it continues traveling farther from Earth than any human-made object in history, sending faint signals across billions of miles of space. Every transmission is extraordinary. By the time a message from Voyager reaches Earth, it has traveled for more than 20 hours at the speed of light. The signal is unimaginably weak, buried beneath layers of cosmic and electronic noise. Engineers must carefully isolate it, correct transmission errors, and reconstruct the data before it can be understood. Most of the time, those signals simply tell the story of an aging spacecraft. They report its remaining power, the health of its instruments, and the harsh conditions of interstellar space. But occasionally, something unexpected appears. Tiny variations emerge within the data, subtle enough to be overlooked, yet unusual enough to demand closer examination. The first assumption is always the simplest. After nearly 50 years in space, Voyager's hardware is aging. Electronic components experience radiation damage, temperatures fluctuate, and instruments gradually lose precision. Any unusual reading could easily be the result of a spacecraft approaching the limits of its remarkable lifespan. Yet science depends on careful investigation rather than quick conclusions. Researchers compare every anomaly with previous observations, computer models, and known physical processes. They ask whether the change originated inside the spacecraft or whether it reflects conditions in the environment surrounding it. That distinction is crucial. If the source lies within Voyager itself, the mystery ends with engineering. If the surrounding environment influenced the signal, the data could provide valuable insight into a region of space that humanity has barely begun to explore. Interstellar space is often described as empty, but that description is misleading. Beyond the Sun's protective heliosphere lies an environment filled with thin clouds of gas, charged particles, magnetic fields, and high-energy cosmic rays. It is an ocean of invisible activity stretching between the stars, shaped by ancient stellar explosions and the constant motion of our galaxy. Voyager is not observing this environment from a distance. It is traveling through it. That makes every measurement uniquely valuable. Unlike telescopes on Earth, Voyager experiences these conditions directly, recording changes that cannot always be observed from millions or billions of kilometers away. Scientists have already confirmed that the spacecraft crossed the heliopause, the boundary where the Sun's influence gives way to interstellar space. Since then, its instruments have measured unexpected variations in particle density, magnetic fields, and cosmic radiation, helping researchers refine their understanding of this distant frontier. Each new discovery reminds us how much remains unknown. The space beyond our solar system is not a featureless void. It contains invisible structures, drifting clouds of plasma, magnetic turbulence, and countless objects too cold or too dark to detect easily with conventional telescopes. Some may be rogue planets wandering between the stars. Others may be fragments left behind by ancient planetary systems or dense regions of interstellar materials slowly moving through the galaxy. Most are entirely natural, yet each represents another piece of a cosmic puzzle that scientists are only beginning to assemble. Voyager's mission has become something far greater than its creators imagined. It is no longer exploring planets. It is exploring the vast region between stars, a place where every new measurement expands humanity's understanding of the galaxy we call home. Perhaps the greatest lesson from Voyager is not that it has answered every question. It is that every answer reveals another mystery waiting beyond the horizon. As long as its instruments continue to function, Voyager will remain humanity's most distant witness, carrying the story of Earth into a darkness that no human has ever visited. And somewhere ahead, beyond the reach of the Sun, the universe still has countless secrets waiting to be discovered. The farther Voyager 1 travels, the more extraordinary its journey becomes. Every kilometer it covers takes it deeper into a region no spacecraft was originally designed to explore. It has moved beyond the familiar influence of the Sun and into an environment where the rules feel unfamiliar, where every new measurement challenges what we thought we knew about the space between the stars. For decades, scientists believed interstellar space would be relatively quiet. Instead, Voyager revealed a dynamic environment filled with shifting magnetic fields, energetic particles, and invisible currents flowing through the galaxy. These discoveries transformed our understanding of the frontier beyond the heliosphere. What once seemed like an empty void turned out to be an active cosmic landscape, constantly shaped by forces operating across unimaginable distances. Yet every answer brought another mystery. Small variations continued to appear within Voyager's observations. None were dramatic enough to suggest an extraordinary event, but each required careful analysis. Every unusual reading had to be compared against years of archived data, computer simulations, and our current understanding of plasma physics. Sometimes the explanation was straightforward. An aging instrument. A fluctuation in background radiation. A temporary change in the surrounding plasma. Other times, the answer remained uncertain. That uncertainty is not a weakness of science. It is how science moves forward. Researchers do not rush toward extraordinary conclusions. Instead, they test every possibility, eliminate every ordinary explanation, and allow the evidence to guide the story. This careful process has made Voyager one of the most valuable scientific missions ever launched. Unlike telescopes that observe the universe from afar, Voyager experiences its environment directly. It measures conditions from inside a region humanity has never visited before, providing information impossible to collect in any other way. Each transmission becomes another chapter in our exploration of the unknown. The spacecraft itself has become a remarkable engineering achievement. Designed for a mission lasting only a few years, it has continued operating for nearly half a century under conditions its creators could scarcely imagine. Its power supply grows weaker with every passing year. Engineers have gradually switched off non-essential systems, preserving only the instruments capable of returning the most valuable scientific data. Every watt of electricity is carefully managed. Every command sent from Earth is planned months in advance. Despite these limitations, Voyager continues to exceed expectations. Its endurance reflects not only brilliant engineering but also humanity's determination to explore places beyond our immediate reach. Looking ahead, scientists know that Voyager's voice will eventually fall silent. Its power source will no longer be able to support its remaining instruments. One by one, they will shut down until no signal returns to Earth. But even then, its journey will not end. Voyager will continue drifting through the Milky Way for millions of years, carrying the famous Golden Record, a collection of sounds, music, greetings, and images created to represent life on Earth. It is less a message to extraterrestrials than a time capsule from our civilization. A reminder that one small world once looked toward the stars with curiosity instead of fear. Perhaps no one will ever discover it. Perhaps it will travel forever through the darkness without another witness. Yet its existence says something profound about humanity. Long before we possessed the technology to cross the galaxy, we found the courage to send a tiny piece of ourselves into the unknown. That spirit of exploration remains Voyager's greatest legacy. Not because it answered every mystery, but because it inspired us to keep asking questions. Somewhere beyond the distant glow of our sun, Voyager continues its silent journey, moving deeper into a universe far larger than our imagination can fully grasp. And with every passing year, it reminds us that the greatest discoveries often begin with a simple decision: to keep going, even when no one knows what lies ahead.